Good morning, everyone. Today, we are going to explore two fascinating mathematical tools. First is beta, and the second one is the gamma function. This is an important part of integration because it helps out to solve very important integrals. Now, these functions in the beginning might sound intimidating to you, but I assure you by the end of the lecture, you will be seeing the clever ways to solve the problems. Further, we start with the basic, that is the gamma function. So what do we mean by the gamma function? Basically, the gamma function is like factorial. So how it is like factorial? I'll say, for example, I think you know what a factorial is. For example, if I say 5 factorial, how do you write it? 5 into 4 into 3 into 2 into 1, and that is equal to 120. Yes. But if you would have read permutation and combinations, you must know that factorials are only for whole numbers. Yeah, you might know 0 factorial is equal to 1. But here is the interesting case. What if I say 2.5 factorial? Now, for many of you, you would say it doesn't exist. But here the gamma function comes in. It generalizes factorials to for all real numbers. So gamma function generalizes factorials for all real numbers but except negative integers. Negative integers don't come into play here. Now, beyond all that, now let's get to know what a gamma function is. So mathematical tool for the gamma function looks like this. So if we say the formula for the gamma function can be written as tau of n. So we say tau of n can be written as 0 to infinity x to the power n minus 1 e to the power minus x dx. Don't worry, this integral might look tough, but I'll tell you simpler ways to calculate. Now, how to calculate gamma values? So calculating gamma values is easy. How do we do it? Just remember the definition and as well as remember this way. For example, if somebody asks you tau of 4, so you will say just this is 3 factorial and that is equal to 6. If somebody asks you tau of 5, you will say it as 4 factorial and that is equal to 24. Now, these are easy ones, but if somebody asks you what is tau of 1 by 2, now this is interesting. This is equal to root of pi. Yeah. Oh, what a connection with pi. Connection with pi. Now, you would ask me another question. How it is possible? So, just think over it and we'll get to know the answers at the end of the video. So, now apart from this, what are the real life applications for gamma function? What is the real life application? So there are lots of real life application. It is used in probability, it is used in physics and engineering. It also helps to calculate the time of radioactive particle decay. So it also helps to calculate the radioactive time decays, or it also helps in calculating the distribute of wait times in a queue. So basically this is all about gamma function. We will see with the help of examples and questions later on. But before that, we'll come to the part 2 of it, and that is the beta function. So part 2, that is the beta function. So what is meant by beta function? Now beta function, it is, you can say it is the cousin of the gamma function. Now it is a way to combine two numbers into a single value, which is often used in probability and statistics. Now, how do we combine two numbers into a single value? Let's see. So basically we'll write out the formula for beta function first. So formula for beta function looks like b of xy is equal to 0 to 1 t to the power x minus 1 1 minus t per power y minus 1, and that is dt. See, x and y are the values of numbers, and where t is some random variable for which we have to do the integration. Okay, just remember, if you are not able to remember the integral, just remember one thing, that it is a way to blend two numbers together. Now, so basically next thing comes, why study beta and gamma function together? So what is the connection to gamma function? So the connection to gamma function is like this. B of xy can also be written as tau of x into tau of y divided by tau of x plus y. So this makes it easier to calculate. Once you know gamma values, then you can calculate beta function or beta values. For example, I can give you one example which is simple to understand. Say if somebody asks you beta 2 comma 3, so you will say that as gamma 2 into gamma 3, sorry, this is gamma of 3 divided by gamma of 5. So now how do you calculate gamma of 2? It will be 1 factorial, gamma of 3 will be 2 factorial, and gamma of 5 will be 4 factorial. So this will be 1, 2 divided by 24, that is equal to 1 by 12. Now again, if you remember this, that beta of 1 by 2 and 1 by 2 will be equal to gamma of 1 by 2 and gamma of 1 by 2 divided by gamma of 1, that is 1 by 2 plus 1 by 2. So gamma of 2 is root pi into root pi, and therefore this 0 factorial, which is 1, so this is equal to pi. So even beta function can be related to pi. Now what is the real world application? Why do we study this beta function? So the basically it is used in Bayesian statistics. Now this is another topic which we are going to deal later when we study for higher mathematics, and it is used to model probabilities in machine learning for probability distributions, and it is also used in physics for particle interactions. Now, so we have connected beta and gamma function. Now, so why are they related? The question says, why are they even related? Actually, both deals with integrals and factorials, but they solve different problems. For example, the gamma function generalizes factorials, that is for real numbers except for negative integers, but beta function combines probabilities. This combines probabilities. So let's take one of the example. You try to solve, otherwise I'll solve it as soon as the I'll give you a minute to understand how to solve it. For example, if I say there is a probability problem and I need to solve this probability problem using beta and gamma functions. So what is the question? The question says, suppose you have a biased coin and you want to find probability. Now what probability do you need to find? You need to find probability of getting 3 hits and 2 tails in 5 flips. So how would you find it? Now this beta function is going to help us out. So this beta function is going to help us out. Now it's simple. How you do it? Think for a minute and I'll tell you the solutions. Now before that, I told you that gamma of 1 by 2 was root pi, and I told you that I'll tell the solution at the end. So let's see how it is. So we say tau of n is written by 0 to infinity x to the power, so it will be x to the power n minus 1 e to the power minus x of dx. Now suppose if I put n is equal to 1 by 2, it says tau of 1 by 2 is equal to 0 to infinity x to the power 1 by 2 minus 1, that is minus 1 by 2 e to the power minus x of dx. Now we can substitute. How do we substitute? Let's say x is equal to t square. So dx will be 2t dt. Now since we have to change the upper and lower limit also, we say when x equal to 0, t is equal to 0, and when x is equal to infinity, of course t is also tending to infinity, so tau of 1 by 2 will become 0 to infinity again, so it will be t square per power minus 1 by 2 e to the power minus t square into 2t dt. So again, if we further evaluate, tau of 1 by 2 will be equal to 0 to infinity. So this 2 will get cancelled, and again there will be some 2 that will be outside, and this will become t to the power minus 1 e to the power minus t square into t dt, and hence t and t inverse will get cancelled. So basically what we are left out with? We are left out with tau of 1 by 2 is equal to 2, 0 to infinity, and this will be e to the power minus t square into dt. Now this is a very famous integral. Now 0 to infinity e to the power minus t square dt is also known as Gaussian integral and is equal to root of pi by 2. This value is always equal to root pi by 2, and hence if we are required to find twice of this value, so basically even we can prove it that how e to the power minus t square dt is equal to root pi by 2, but it is actually the further it will be dealt when we are dealing with multiple integrals. So for now you just remember 0 to infinity e to the power minus t square dt is equal to root pi by 2. Hence tau of 1 by 2 will be equal to 2 into root pi by 2, which is equal to root pi, and hence the answer. Now so this is the value. Next I'll say कि gamma function will basically be used in quantum mechanics also, statistical mechanics also. It is also used to solve certain differential equations, but here we'll be restricting ourselves to some questions basically from maths, and it will be further developed as we read on to more of the topics. Now I gave you one question to think about. The question was, you have a biased coin and you want to find probability of getting 3 heads and 2 tails in 5 flips. Now this is in class 12th. You must have read probability for unbiased coin. That is, the probability of getting heads and tails will be equal, which is equal to 1 by 2 for each if there is a single coin for it. But here if you have a biased coin, the probability of head is not necessarily 0.5. Yes or no? So here beta function comes in. Now this is a very nice question. and let's see the solution. We have 3 head and 2 tails and we have a biased coin. So the solution for the given example will be like this. Now let's say some beta function x comma y. How do we write it? We say 0 to 1 t to the power x minus 1, 1 minus t per power y minus 1 and dt. So beta of xy is also written as tau of x into tau of y, which is related to gamma function tau of x plus y. Now, how do we model the problem? We have 3 heads and 2 tails. Remember, we have 3 heads and 2 tails. Now, so what do we say? The probability of getting, suppose the head as p. So the probability of tail will be 1 minus p. Yes or no? Since if a coin is flipped, either we can get head or tails, and the probability of getting both will be 1. So if p is the probability of getting head, then 1 minus p will be the probability of getting tails. And alpha and beta define the shape of the distribution. Define the shape of the distribution. Now, so if we say define the shape of the distribution, so if I write say some parameter, that is the probability density function for it. So if we write the probability density function, that is PDF. Now this will be equal to f p alpha comma beta, which is also equal to p to the power alpha minus 1, 1 minus p to the power beta minus 1 divided by b of alpha beta. This is known as probability density function. Now p is the probability of heads, alpha and beta parameters that define the shape of the distribution. Now we have 3 head and 2 tails. So how do we write alpha and beta? Remember, in this case, since it is a beta function, remember alpha shall be equal to 3 plus 1, that is 4. Why? Because 4 factorial, remember that was, if I write tau of 4, it was equal to 3 factorial. So alpha will be 3 plus 1. Again, beta will be 2 plus 1, that is equal to 3. So uh, you will ask why we are adding 1, because see, we add 1 to each count because the beta distribution starts counting from 0. So that's why here we'll add 1 to each. Now, so the function PDF becomes fp, that is 4 comma 3, which is equal to p 4 minus 1, 1 minus p, that is 3 minus 1, divided by b of 4 3, where b stands for beta function. Now this will be p cube 1 minus p ka whole square divided by beta of 4 comma 3. Now if we calculate b of 4 comma 3, remember this is equal to tau of 4 divided by tau of 3 by tau of 7. So this will be 3 factorial into 2 factorial divided by 6 factorial. Now which is equal to, so this will be 654 divided by 2, which is 516, 1 by 60. Now substitute the in the probability density function, which is p 4 comma 3, which will be equal to p cube 1 minus p ka whole square divided by 1 by 60, that is equal to 60 p cube 1 minus p ka whole cube. No, it's not whole cube, it's whole square. So 1 minus p ka whole square. Now what we were required to find out? We were required to find out the probability of, so basically what our intention was, we are required, now we got the probability distribution function. Now it's, we have to find out probability of 3 heads and 2 tails, which will be written as 5, since there are total 5 flips, out of which we have to find 3 heads and 2 tails. So we can say either this is 5c3 p cube 1 minus p ka whole square. Here 5c3 will be equal to 5 factorial divided by 3 factorial into 2 factorial, which is equal to 10. Now p is random variable because the coin is biased. We just need to average the value. So how do we average the value? Of course we will be using functions for it. Now so finally we'll say probability of 3 heads and 2 tails can be given by 0 comma 0 to 1 5 c3 p cube 1 minus p square f p, which is 4 comma 3 dp. Now we know what is fp for 3. So this is equal to 60 p cube 1 minus p ka whole square, and therefore the probability of 3 heads and 2 tails will be 0 to 1, that is 10 p cube 1 minus p ka whole square 60 p cube 1 minus p ka whole square dp. And hence if we simplify, the probability of 3 heads and 2 tails will be given by 10 into 60, that is 600, and apart from that this will be p ka cube, that is p to the power 6 1 minus p to the power 4, and that is dp. Now we also need to evaluate the function. So how do we evaluate the function? And this ranges from 0 to 1. Doesn't it look like some beta function? Now what was beta function? Remember, beta function of x comma y was 0 to 1 t to the power x minus 1 1 minus t per power y minus 1 dt. Now here we have 0 to 1 p to the power 6 1 minus p to the power 4 dp, which can be written as p of 7 comma 5. Now if we know, then we can easily evaluate p 7 comma 5, which is equal to tau of 7 tau of 5 divided by tau of 12. Now tau of 7 is equal to 6 factorial into 4 factorial divided by 11 factorial, which is also equal to 11 10 9 8 7 divided by 4 3 24. So this is 3, this is 3, and hence the value will be equal to 1 by 30 210, and 210 into 11, which is equal to 21 2310, 1 by 2310. And hence the probability of getting 3 heads and 2 tails when the coins are biased will be equal to 600. Here you can see this will be equal to 600, and its value is 1 by 2310. So 600 into 1 by 2310. So this will be equal to 377, and this is 20. So 20 by 7, which is approximately equal to 70. This is 0.25 approx. And hence the conclusion is that the probability of 3 head and 2 tails will approximately be 25.97% when in 5 flips of a biased coin. Now you might have understood the usage of beta function. It helps model the probabilities of probabilities, and by combining the beta distribution with the binomial distribution, we can solve problems involving biased coins or other uncertain probabilities. Now this is also used in Bayesian statistics, machine learning, and decision making under uncertainty. Thank you. We will approach now with certain questions.